Imagine you are on a vast ship in the depths of space. Alarms go off and everyone in the control room rushes to their posts. There is a malfunction in the life support systems. The carbon dioxide levels are rising. What is the crew to do to save everyone on board? Let me introduce you to the spaceship we are currently on. It's called Earth, and the warning alarms are sounding. I'm Lady Lee Clinton. Let's talk about global climate change. We are not alone on this spaceship called Earth. We share this crisis with many other countries. Some are taking it more seriously than our country at the moment. Some people don't believe there is a crisis, while others believe humans are not the cause. These viewpoints are dangerous because they delay any chance of lessening the impact. And there are ways that we can make a difference. Let's start by taking a closer look at the problem. There seems to be some confusion over the terms global warming and global climate change. You can think of global warming as a fever, while global climate change is the flu. The fever is only a symptom of having the flu. Global warming is just one symptom of global climate change. We have known for some time that our planet is getting warmer much faster than it has previously. Global warming simply refers to the overall increase in the temperature of our atmosphere and oceans. This intensified warming causes extreme rapid changes to our global climate. Climate is a term that refers to the larger patterns that affect different ecological regions of our planet. People tend to confuse climate with weather. Weather refers to the state of the atmosphere at a particular place and time as regards to heat, cloudiness, dryness, sunshine, wind, rain, etc. It is the current condition that you experience when you step outside. It can change rapidly from day to day or even from one hour to the next. Weather is often dependent on location and season, but it can fluctuate over a given region and time period. For example, the climate of the southwest U.S. tends to be dry and warm during the summer. This means you are more likely to find deserts in this region. The climate of the coastal Pacific Northwest is cool and wet during the winter. This means you are more likely to find temperate rainforests. Climate patterns represent broad areas where fairly consistent seasonal patterns have allowed certain plants and animals to adapt to living there. This doesn't mean that it's always sunny and warm in the desert, or that it's always cool and wet in the rainforest. There are seasonal and daily variations. Climate is influenced by air circulation patterns in Earth's atmosphere. These patterns of airflow create seasonal weather systems around the globe that arise due to the tilt of Earth's axis. Summer occurs when the axis is pointed towards the sun, while winter occurs when the axis is pointed away from the sun. Seasonal patterns can also be influenced by topography. Mountains can alter the pattern by trapping moisture on one side and leaving the other side drier. Land regions near large bodies of water can also be impacted. Water holds heat better than air, so it takes a lot of energy to change the temperature of large bodies of water. This can affect seasonal temperatures as well as winter snow levels. There are also larger oscillations that affect seasonal patterns. One of the best known is the El Niño Southern Oscillation. This changes the jet streams that influence temperature and precipitation patterns around the world. This pattern has been happening for a long time. Scientists aren't really sure why it happens, but they understand the patterns and the related changes in seasonal weather events. When scientists talk about global climate change, they are referring to noticeable shifts in overall patterns within ecological regions, not just the daily local weather conditions. So how do we know that global climate change is actually happening? There are several important indicators that Earth's climate is changing rapidly. One of the most talked about indicators is global warming. There has been a recent increase in the average global temperature considerably larger than previous historic temperature increases. To determine global temperatures, science collects temperature data from thousands of weather stations, ocean buoys, and satellites around the world. The temperature at each land and ocean station is compared daily to what is normal for that location and time, typically the long-term average over a 30-year period. The differences are called anomalies, and this helps scientists evaluate how temperature is changing over time. Using global temperature anomalies eliminates biases that occur because of station location and elevation, and when stations are added or removed from the dataset. Based on scientific data, the best logical reason for global warming is the increase in greenhouse gases, especially methane and carbon dioxide. When scientists measure the amount of greenhouse gases in the atmosphere and compare them to historical levels from ice cores, they have found a dramatic increase. These increases are directly connected to the amount of fuel resources that humans use. We add new fuels without doing away with the old ones, which increases the overall amount of greenhouse gases entering the atmosphere. The most critical of the greenhouse gases is carbon dioxide, because it remains longer in the atmosphere. There is a direct correlation between the increase in carbon dioxide and the increase in global temperatures. Increased carbon dioxide in the atmosphere traps heat and increases the temperature. This allows the air to hold more moisture, increasing cloud cover and trapping even more heat. The ocean also absorbs heat, but at a much slower rate than the air. There have been measurable changes in the heat content of the upper 2,300 feet of the ocean from 1993 to 2017. Another symptom of global climate change is ocean acidification, which occurs when ocean water absorbs too much carbon dioxide. Since the beginning of the Industrial Revolution, the oceans have absorbed approximately a third of the carbon dioxide humans have produced. This has caused an increase of 30% in surface ocean acidity. These indicators create specific impacts for all living things on Earth, especially humans. Global warming causes many significant issues. For humans, the increase in temperature can have serious health risks. These include health-related illnesses, worsening chronic illnesses, injuries and deaths from dangerous weather events, infectious diseases spread by mosquitoes and ticks, illnesses from contaminated food and water, and mental health problems. Global warming also impacts our ability to grow crops. Increasing temperatures create a feedback loop in areas where drought is already a problem. When the ground is dry, heat from the sun does not have to expend energy to evaporate the already dry soil, and instead heats the air to a more intense degree, causing air temperatures to rise. The warmer air also pulls moisture from vegetation and increases the risk of wildfires. Increased atmospheric temperatures means the air can hold more moisture. This leads to increased heavy precipitation events in some areas, while causing drought in others. Increased temperatures also cause precipitation to fall as rain instead of snow. During periods of extended rainfall, the ground becomes supersaturated and cannot absorb any more water, leading to flooding. Impermeable surfaces like streets increase flooding potential in urban areas. Heavy rain events also lead to landslides, mud flows, flash floods, and strain on levees and dams. The increase in ocean surface temperatures affects storm intensity. Hurricanes form over warm ocean waters. The warmer the water, the more energy the hurricane has. Because the warm air can hold more moisture, future hurricanes have the potential to drop greater amounts of precipitation, move slower, and have stronger winds. Increased warming as our climate changes tends to increase the frequency, intensity, and impacts caused by destructive weather-related events. Increased temperatures also cause melting of glaciers and ice sheets. This fresh water flows into the ocean and can affect the ocean conveyor belt that circulates through all the ocean basins. It also causes ocean levels to rise, which can impact people that live along low-lying areas. Many coastal communities in the United States are already impacted by rising sea levels. Large areas of the coast could be underwater with just 4 more feet of sea level rise. Loss of polar sea ice increases the temperature of the air and ocean at the poles. White ice reflects solar energy, while dark ocean water absorbs more energy. Warming in the Arctic also thaws permafrost and releases both carbon dioxide and methane into the atmosphere. Melting ice also increases the amount of fresh water being added to the oceans, which adds to the increasing precipitation. This changes the salinity, the amount of salt concentration. Stable salt densities in the oceans keep the Earth's climate in balance. Even small fluctuations can have a serious impact on major weather patterns. The increasing temperature at the poles weakens the winds associated with the polar vortex and jet stream, allowing colder air to drop farther south in the winter, creating heavy snow events. The oceans are also absorbing about 30% of the carbon dioxide that humans add to the atmosphere. This changes the alkalinity of the water. Ocean water was historically around 8.2 on the pH scale before the Industrial Revolution. Today, surface ocean water averages 8.1 on the pH scale. When the pH of ocean water drops lower, the saltwater becomes more acidic. One of the signs of ocean acidification is coral bleaching. Coral is colorful because of tiny algae that live inside the coral. Temperature and pH changes can stress the coral and kill the algae partner, leaving the coral without a reliable food source. It also affects the ability of the coral to grow. The same chemistry that is affecting coral is also impacting coastal shellfish production. Oysters and other shellfish use carbonate from ocean water as the building blocks to grow their shells. The global ocean has soaked up 1/3 of human-caused carbon dioxide emissions since the start of the industrial era, increasing the CO2 and acidity of seawater. Increased seawater acidity reduces available carbonate, making it harder for oysters to grow. Warming oceans decrease plankton productivity, which not only impacts fish stocks, but could lead to a feedback loop that destroys the food web in the ocean and potentially affects all life on Earth. Phytoplankton are microscopic plants that prefer cold ocean water. They are the base of the entire food web. They are also vital to all living things on Earth. About 2/3 of the planet's total atmospheric oxygen is produced by ocean phytoplankton, and therefore cessation would result in the depletion of atmospheric oxygen on a global scale. This would likely result in the mass mortality of animals and humans. As the surface of the ocean where these microplants live gets too warm, they migrate towards colder water where nutrients upwell from the deep ocean, which decreases the area of the ocean surface they cover. This decreases food sources for zooplankton that feed larger organisms and limits the amount of oxygen being added to the atmosphere. It also decreases the amount of carbon dioxide that would normally be taken up during photosynthesis by these microplants. Phytoplankton sink carbon at the bottom of the ocean when they die, but with less phytoplankton, there will be less carbon sequestered. Surely, with all of these warning signs, humans should be doing something to limit the amount of greenhouse gases in the atmosphere. The first step is to stop ignoring the problem and accept that it's happening. The second step is to change what we can right now. Just by making a few changes to the way we live, we can decrease the amount of energy we use by swapping light bulbs to more efficient LED types, turning off lights when we aren't in a room, unplugging charging cables, using less hot water, taking public transit when possible, and planting more trees. Then we must address the long-term issues. Renewable energy is often regarded as the answer to long-term climate recovery. However, there is a debate whether the United States can afford to move completely to renewable energies soon enough. There are also environmental impacts, even with green technology. We need economically feasible ways to combat the causes of climate change right now. One important step might be to remove some of the greenhouse gases that are causing the problem. Methane can be captured and turned into fuel. We need to find ways to decrease the amount of CO2 we add to the atmosphere. Cement, which is usually added to concrete, produces high CO2 emissions during manufacturing. By replacing some of the cement with other materials, we can decrease some of the emissions. If CO2 is added to the concrete, it could act as a carbon sink instead. We need to invest in more carbon capture technology. CO2 can be made into fuel that can be used in the vehicles we drive right now. Carbon dioxide is also used to feed plants in hydroponic farms. There are many possible ways to turn this overabundant problem into financial profit. Careful monitoring of conditions is essential. We don't want to cause more problems by removing carbon dioxide while not controlling other greenhouse gases. China is currently facing a serious health threat from increased ozone at ground levels because of how quickly they removed carbon dioxide without paying attention to the chemicals that contribute to ozone. We must also plan ahead to help those who will be harmed or displaced by the impacts of climate change. With stronger hurricanes and tornado seasons, increased flooding of rivers and ocean coasts, and increased fire danger possible in the near future, we must ensure that FEMA has enough funds. Long-term assessment plans should be considered when planning for new development in high-impact areas. New housing technologies could improve safety in tornado-prone areas as well as improve energy efficiency. Flood control designs could be implemented in areas prone to flooding. Underground reservoirs could be a sustainable way to control flooding in urban areas, as well as providing water during times of drought. Climate change seems like a big problem to tackle until you break it down into manageable steps. By making easy changes now, finding ways to make climate recovery financially lucrative, and planning for future disaster relief, we can leave a better world for future generations. I'm Lady Lee Clinton. Thank you for your time.